Okay, I'm going to keep an object somewhere here. Then I'm going to weave it from here. Okay, this is slab of thickness T. Refractive index, let me keep it this as mu1. Already the apparent shift, what we studied, those concepts only I'm going to apply, not something new. Now, the refractive index of slab be mu2, surrounding medium, let it be mu1. This is mu1, and this is mu1. Let me keep below. Okay, where do the object will appear? I think this is a very quite natural thing. You try to weave an object through a thick glass slab, then where do that object will appear for us? Okay, we'll stick on to the basic, like first the incident ray emitted by the object. It will emit the rays in all direction. It will emit rays in all direction. I'm just considering the incident ray which is striking this surface. So let me call this is P1. This surface as P2. Now let's assume that this is the denser medium. This is rarer. So what is the assumption? Denser, rarer, rarer. So the ray is moving from rare to denser medium. So it will undergo the refraction, the refracted ray. Will show like this. So this I'll produce it back. So here is what the image I1 will come. Again, the ray is going to move from denser to rarer. It should bend away from normal. So the emergent ray will be finally here. So the object where it was, actually it is. What do you mean by object? Some flower. Now where the final image will be here, that one. So I'll say like a, can you keep flower? Okay, let's go for flower. Now where did it appear? It will appear here. There's a basic idea. You must have a background of these kind. What is object? Object is a real. The image flower, what you are going to see, that is a virtual. There's a basic idea, this one. So there's a real. Now why virtual? Because the refracted rays, you can also send a rays here. So this image is formed by the diverging refracted rays. No, the diverging refracted rays enter into eye, and the eye will see the virtual image of this one flower. So it will appear nearer, no? So it will appear nearer. So this part is what? The shift. We have to calculate this shift on what all parameters it depends. Okay, here first it will undergo refraction at M, then at N. So what we can do? So this is the no, normal. Okay, this is the angle of incidence, theta 1, theta 2, theta 2, and this is theta 3. So you can apply the Snell's law and you have to solve this. Nothing big, that one. So what is the basic Snell's law? So at M it will be mu1 sine theta 1 equal to mu2 sine theta 2. At N mu2 sine theta 2 equal to mu3 sine theta 3. And we do discuss for paraxial rays. What do you mean of paraxial rays? The rays, the M will be very close to the P1. So for paraxial rays, theta will be very small, sine theta will become tan theta, then you have to further solve it, tan theta 1, so this will become tan theta 1. This will become tan theta 1, this will be tan theta 2, this will be theta 3. So from the triangles P1, M1, from there we are supposed to solve this. There's a one method. Huh? Okay, fine. So here for paraxial rays, theta very small, so therefore sine theta will become tan theta 1. Now what we have to calculate? We have to calculate that shift S. That is our requirement. So there is a one method. So from using Snell's law solving, we can do it. Already we know the apparent shift. So can't we use apparent shift? Yes, it is. So suppose say that you are here. You are here. So how you can apply this slab? Let's assume that you are here. So where is the object? Object is in random medium. You actually you can solve by this method. Tan theta 1, tan theta. What is tan theta 1? Use this triangle. P1m by P1o. Then tan theta 2 will be directly straight away from here, no? P2n by P2I1. Tan theta 3, P2n by P2I. So we'll get the required things. Hmm? So that is a one method. Try that method. Let me show you by another method which we usually prefer in the numericals. Suppose say this is the okay. This is an object. Okay, this is the brown color one. No, where is the brown color? It is here. This is the image, no, I1. So this is mu1. This will be mu2. So we are not understanding. Okay, I'll go like this. At least now, okay. So where the refracted ray is present in the medium of refractance mu2, and if you are here, if you are here, then where is the object? Object is here. So this will be P1O. So any formula for P1I1 apparent depth, this will be like a rarer medium. This is a denser medium. So if this person weaving, so this will become boundary, no?
H
This
by
will
mu
become
we can,
boundary. P1I1. I want from anybody answer.
P1O by
Ah,
P1O mu2 by mu1.
yes sir, P1O mu 2 by mu 1.
P1O mu2 by mu1. P1O. This is very important. See, what you learned now, can you apply this? Finally, it matters a lot because almost all numericals, we will use this approach. We can solve by this one. There's a more mathematical one. This will help, this is going to help us a lot. P1I1 equal to P1O by mu2 by mu1. Okay, fine, till here. What we needed, only we needed this distance. So it is something like P1O minus P1I. Now let's come for this one. After refraction, okay, this I1 will become object for this interface, and the eyes, the green color rays, what will read the eye. Though this I1 is there in the rarer medium, you have to treat as if it is coming from I1, no? So here the approach will be little bit different. Please try to understand. This will going to really help you a lot. No, this will be everything the medium. Though I1 where it is in rarer medium, but For the eyes, what will happen as if the rays are coming from I1, as if they are coming from the medium of refractiveness mu2. Here's what I am here. So this is the human eye. Or we'll take another person. Is here. So then this M2. So where is the I1? I1 is here. The rays are coming as if from I1. So after refraction, and this is the boundary. I'll bring brown color. Where is that brown color? It is like this.
Sir? Sir, P1O into mu1 by mu2 should come, no, sir?
What is the refractiveness of the medium in which object is there? You are weaving from a medium of refractiveness mu2. Okay.
Yes,
Suppose
sir, yes.
huh?
Got it, sir.
Not like denser rather, in which
Uh,
medium you are weaving. Huh?
okay, sir. Yes, sir, yes.
I'll action this. We will write this is I. Rather than denser, rather better call mu2 mu1. There'll be more better approach here. And this is what P2. This was P1, we took it here. Now, can we write any equation here? P2I. Now, where is the object? Object is in a medium of refractance mu2, and the view from a medium of refractance mu1. And where it will appear? It will appear at I. So, any formula for P2I?
P2I1 mu1 by mu.
Yes.
Yes, sir. P2I1 mu1 by mu2.
P2I is equal to P2I1 mu1 by mu2. Okay, now this is the formula. Now these are the things which we are going to take help of it. Now what is needed? We needed just like the shift, no? P2 P2I can I write P1 plus P2 plus P1I? So some adjustments will make it here, and P2I1 also I'll make it adjustment. So this is about the background. Okay, now we'll go for the calculation part. P2I further, P2I equal to P2I1, I'll write it as P2 P1, P2 I1, P1 I1, mu1 plus mu2. P2 P1 is T. P1 I1 already I have here this particular thing. I'll substitute that one, so that will become P1 O. Now what is needed for us, like a P2I minus P1O, or P1O something. Okay, let me go for the next part of calculation, the shift S. Shift S is equal to, this will be P2O minus P2R. P2O is P1 plus P2, or say P2 plus P1 plus P1. P2I already we have calculated, so T plus P1O P1 P2 is T plus P1O. P1O also get cancelled, so we'll end up with 1 minus mu1 by mu2. Very important formula. You check the book, no? There are around 25 numericals are there based on this, not one, two. This is a theory, nobody will ask you to derive this, only in IP exam next year at this time. But all the competitive exams, you need this formula. You should know how to use this formula. You can solve by the Snell's law, that one. So, but in the most of the numericals, no, we need approach of this one. That's why I just preferred it. What do you mean by mu1? Refractive index of surrounding medium. What do you mean by mu2? Refractive index of the slab. If the surrounding medium is air, then mu1 will become equal to 1. If surrounding medium is air, then mu1 will be 1. Okay, I'll just highlight it. Anybody having doubt, please clarify. I'll go for the applications of this one now. You should try to solve by this method. There's another alternative method, mathematics. This little bit you have to apply more triangle solve. You can have this approach also and you'll get the same answer. No? Try it. No? Okay, now after getting this formula, we'll move on to the how to use this formula. What is the mu1, mu2, all that one? So it is a shift in the direction of incident ray.